Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve the exponential problem 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8. Now, to solve this problem, what I'm going to do is, I first have 4 answer choices. So my first answer choice A, this is going to be 8 to the power of 32. My second answer choice B, this is going to be 32 to the power of 8. My third answer choice C, this is going to be 32 to the power of 32. And my final answer choice D, this is going to be 2 to the power of 26. So if you guys know how to solve this problem, you guys can try to find out which answer choice this is. Alright, so now, to solve this problem, let's first go through all the answer choices, starting with A. How they got A was they kept the base the same, so they did 8 to the power of, then they added all the exponents, so 8 plus 8 plus 8 plus 8. And this is equal to 8 to the power of 8 plus 8 is 16, 16 plus 8 is 24, 24 plus 8 is 32. And this method is actually wrong. You can't add exponents like that. So for the secondary choice B, they got 32 to the power of 8, and how they got this was they kept the exponents the same, and they added the bases. So they did 8 plus 8 plus 8 plus 8 to the power of 32. To the power of 8. Now, 8, this is the same thing as 8 to the power times 4, which is 32. So I got 32 to the power of 8. And this method is actually wrong as well. This is not the right way to add exponents. Now, for 32 to the power of 32, they did both. They added all the exponents and the bases. So they did 8 plus 8 plus 8 plus 8 to the power of 8 plus 8 plus 8 plus 8. And they got 32 to the power of 32. And this method is wrong as well. Finally, for D, which is actually the right answer, they first started with, 8. This is the same thing as 2 to the power of 3, right? So we have 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8. And now if I substitute in 2 to the power of 3, I get 2 to the power of 3 to the power of 8 plus 2 to the power of 3 to the power of 8 plus 2 to the power of 3 to the power of 8 plus 2 to the power of 3 to the power of 8. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, a is equal to 2, m is equal to 3, and n is equal to 8. So now I have 2 to the power of 3 times 8 plus 2 to the power of 3 times 8 plus 2 to the power of 3 times 8 plus 2 to the power of 3 times 8. Now 3 times 8, this is the same thing as 24. So now I have 2 to the power of 24 plus 2 to the power of 24 plus 2 to the power of 24 plus 2 to the power of 24. Now from this, I'll factor out 2 to the power of 24. So now I have 2 to the power of 24 times 2 to the power of 24 divided by 2 to the power of 24 is 1. So I have 1 plus 1 plus 1 plus 1. And if I simplify this in the parentheses, I get 2 to the power of 24 times 4. 4 is the same thing as 2 squared. So now I have 2 to the power of 24 times 2 squared. And now if I have something in the form a to the power of m to the power of n, this is equal, if I have something in the form a to the power of m times a to the power of n, this is the same thing as a to the power of m plus n. So 2 to the power of 24 times 2 squared, this would be 2 to the power of 24 plus 2, which is equal to 2 to the power of 26. So this is why our right answer is D. Now it's time for our bonus problem. 3,111 squared plus 2,889 squared. Now the first thing I'm going to do is I'm going to rewrite this as 3,000 plus 111 squared plus 3,000 minus 111 squared. Now I'm going to set A equal to 3,000, and I'm going to set B equal to 111. So now, if I substitute these in, I get A plus B squared plus A minus B squared. Now A plus B squared, this is equal to A squared plus 2AB plus B squared. And A minus B squared, this is equal to A squared minus 2AB plus B squared. So now, if I add these two together, I get A squared plus 2AB plus B squared plus A squared minus 2AB plus B squared. So first off, these two will cancel out, and I'll be left with A squared plus B squared plus A squared plus B squared, which is equal to 2A squared plus 2B squared. Now if I factor out 2 from this, I get 2 times A squared plus B squared. Now remember how we set A equal to 3,000 and B equal to 111. So now if I substitute these values back into here, I get 2 times A squared, so 3,000 squared, plus B squared, so 111 squared. Now 3,000 squared, this is the same thing as 3,000 times 3,000, right? And you may think this is hard because it's a 4-digit number times a 4-digit number, but we can actually for now ignore the zeros and we can just do 3 times 3. So that would give us 9, right? And then we simply add all the zeros after. So we're going to add 1, 2, 3, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 6 zeros. So our answer here is going to be 9 million. So now I have 2 times 9 million plus 111 squared. Now for 111 squared, this is equal to 111 times 111. Now, if we try to do this, 1 times 1 is 1, 1, 1, 1, 1, 1, 1, 1, 1. So I have 1, 2, 3, 2, 1, which is our answer. Now, 9 million plus 12,321 is going to be 9 million, 2 times 9012321. And this is going to equal 18,024,642. So this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 9 to the power of x minus 6 to the power of x is equal to 4 to the power of x. Now what I'm first going to do is I'm going to divide both sides by 4 to the power of x. So now I have 9 to the power of x minus 6 to the power of x over 4 to the power of x is equal to 4 to the power of x over 4 to the power of x. So then these two cancel out. So now I have 9 to the power of x minus 6 to the power of x over 4 to the power of x is equal to 1. Now, if I have something in the form a minus b over c, this can be written as a over c minus b over c. So 9 to the power of x minus 6 to the power of x over 4 to the power of x, that can be written as 9 to the power of x over 4 to the power of x minus 6 to the power of x over 4 to the power of x. This is equal to 1. Now, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 9 to the power of x over 4 to the power of x, that's going to equal 9 over 4 to the power of x. And 6 over x over 4 to the power of x, that's going to equal 6 over 4 to the power of x. Now, 6 over 4, the greatest common factor of these two is 3. So 3 times 2 is 6. Or sorry, not 3. The greatest common factor is 2. 2 times 3 is 6, and 2 times 2 is 4. So 6 over 4 simplifies to 3 over 2. And we still have 9 over 4 to the power of x. Now for 9 over 4, 9 is equal to 3 squared, and 4 is equal to 2 squared. So I have 3 squared over 2 squared to the power of x minus 3 over 2 to the power of x is equal to 1. Now, remember, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 3 squared over 2 squared, that is going to equal 3 over 2 squared, and we have this to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And these two are interchangeable, meaning this is also equal to a to the power of n times m. So if all of this is true, then this must mean that a to the power of m to the power of n is equal to a to the power of n to the power of m. So right here we have 3 over 2 to the power of 2 to the power of x, and that is going to be equal to 3 over 2 to the power of x to the power of 2. Then we still have minus 3 over 2 to the power of x is equal to 1. Now I'm going to let 3 over 2 to the power of x equal the variable u. So now I have u squared minus u is equal to 1. And now I can subtract 1 on both sides. So I get u squared minus u is equal to, u squared minus u minus 1 is equal to 0. So now I have a quadratic equation, and I can go ahead and plug this into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So I have, if I plug these values in, negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1. All of this divided by 2 times 1. Now, negative of negative 1 is positive 1. So I have positive 1 plus or minus the square root of negative 1 squared is 1 minus 4 times 1 is 4. 4 times negative 1 is negative 4. Divided by 2 times 1 is 2. This is equal to 1 plus or minus the square root of 1 plus 4 over 2. It's equal to 1 plus or minus the square root of 5 over 2. So u is equal to 1 plus or minus the square root of 5 over 2. Now remember, we set u equal to 3 over 2 to the power of x. So right here, we have, this is actually two solutions. We have 1 plus the square root of 5 over 2, and we have 1 minus the square root of 5 over 2. So let's start with 1 plus square root of 5 over 2. So I have 1 plus the square root of 5 over 2 is equal to 3 over 2 to the power of x. So what I'm first going to do is I'm going to take the log of both sides. So I have log 3 over 2 to the power of x is equal to log 1 plus square root of 5 over 2. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front of the logarithm. So this would equal b times log a. So now I'm going to move this exponent x to the front of the logarithm. So now I have x times log 3 over 2 is equal to log 1 plus square root of 5 over 2. Now, I actually took, when I said log on both sides, this was to the base of 3 over 2. So if I have x times log base 3 over 2 of 3 over 2, these two will simply cancel out, and this is also base 3 over 2. And I will have x times 1 is equal to log base 3 over 2 of 1 plus the square root of 5 over 2. So now this means that x is equal to log base 3 over 2 of 1 plus the square root of 5 over 2. Now, this is the same thing as x is equal to log 1 plus square root of 5 over 2 divided by log 3 over 2. And if I have something in the form log a over b, this is equal to log a minus log b. Meaning log of 1 plus square root of 5 over 2, that's going to equal log 1 plus square root of 5 minus log 2, and log 3 over 2, that's going to equal log 3 minus log 2. Now this is equal to 0.51 minus 0.301 divided by 0.4771 minus 0.307. And if you simplify this, you get x is equal to 1.868. Now we got to take a look at our second equation, which is 1 minus square root of 5 over 2. Now if 3 over 2 to the power of x is equal to 1 minus square root of 5 over 2, well, this is actually not possible, because the 1 minus square root of 5, that is going to be a negative number. And you can't take the power of a positive number and make it a negative number. So, meaning this has no solution, and our only solution is x equals 1.868.